chemistry. Okay, so last week we introduced chapter 1 and 2, and in the chapter 1 we introduced the development history of chemistry. And yeah, question. Yeah, I think it works. Can you see? Oh, no. Oh, you mean when we finish and down now? I think I still see now. Okay, so and in the chapter 2, we also introduced, we know chemistry is about matter, and the matter is made by atoms, right? And basically for each element, it has its own atom, and different elements have different atoms. So basically, we can't change one element to another element because we can't change one atom to another one. Okay. So we also introduced the model, the atomic series about atomic series. So we introduced several models. Well, we know basically the atom has the electrons. So in this chapter, we will introduce the electrons in atoms and the periodic table of elements. So in this chapter, we will introduce the Schrödinger equation. And of course, this equation is very complex. It's very complex. But here we just very simply introduce this equation. And we also introduce the periodic table of the elements. I think you should have learned something about the periodic tables, right? Okay. So, okay, we know this is the periodic table of elements. So in this table, we can say, so basically we can put all elements into the table. And also, of course, it depends on the numbers of their electrons. For example, for hydrogen, we know the first atom is hydrogen, right? And the hydrogen only has one electron. And the second one is chlorine, so it has two electrons. So we according to the numbers of the electrons, so we can put all elements into the table. And basically, for each column is called group. So in each group, they have similar electron configuration, and of course we will introduce what is the electron configurations of atoms. Because they have the similar electron configurations, so they show similar chemistry properties. Okay. So here, so firstly, we need to introduce the electrons in atoms. And last time we introduced the atomic series. So we know they are like a Dalton, right? The first one is Dalton model. The second one is the Thomson model. The third one is Rutherford model. And then Bohr model. But now the current model is called electron cloud model. So in this model, so the electrons occupy regions of space. Last week we introduced in the Bohr model, the electrons should move in an octet, right? In a certain octet, each electron moves in a certain octet. But in the electron cloud model, so electrons is like they are occupying regions of space. So this is also called electron cloud. Electron cloud. So this means one electron is not just stay in one orbital. It will like occupy the space. And of course, they have energies. Each electron has energy, and of course, and different electrons may have different energy. And so we can use the Schrödinger equation to represent the movement of electrons. We know, and in physical, we know the light has both wave nature and particle nature. So do you know what is wave nature and the particle nature? So do you have any idea about the nature of the light? I think you should learn this in physical class. So basically, it means the light can be seen as like it's a wave. Okay. It also can be thought as a particle. Okay. So the electron also, we know it's easy to understand that the electron is a particle, right? Because it can go through the space and heat something. But it also has the wave nature. Okay. So when we study its wave nature, we can use the equation. This equation is called Schrödinger equation. We can use this equation to describe its movement. And of course, for this equation is very complicated. Okay, right? And but here we don't need know how to get this equation. Okay, how to get this equation? We just need to know what some important keys, some keys in this equation. For example, basically for this equation describes the energy of electrons. Okay, so the first one, we can know the energy of the electrons from the equation. Okay. And we also can see probability of finding electron in a volume of space. So this is called electron cloud. So this is also the electron cloud theory about the atom. Okay, and so this cloud we also call like shape. Okay, so this means different electrons may show different shapes. Okay, so any question for this? Okay, so basically in this equation, we need to know is that it has four very important numbers. So these four numbers are called quantum numbers. Okay, so quantum numbers, therefore, we can write as N, L, M, L, MS. Okay, so this means for each electron, its energy or shape is decided by these four numbers. Okay. Now we will introduce what these four quantum numbers for quantum numbers. Okay, the first one is n. N is called principal quantum number. Okay, so what n can be? Yeah. So the n can be 1, 2, 3, 4, 5, something like this. Okay, this is what n can be. Okay, so you should remember the first number of the electron is called principal quantum number. So any question?
Can it be 0?
No. I will tell you why it can be 0. Okay, because the principal quantum number means it's represents its energy. Okay, so it can be 0. If it's 0, it means its energy is 0. But we know electron definitely for each electron it has an energy. So the n number, the last n number is 1. Is 1. Okay, yeah, good question. Okay, so and the second quantum number is we can write as L. L is called angular momentum quantum number. Okay, so this is the second quantum number. So second L can be from now n L can be 0. Okay, it can be from 0, 1, 2, 3 to n minus 1. Okay, so think about it. So this means the numbers of n of L are decided by what? N, yes, by n. Okay. For example, if n is 2, so what the L number can be?
1.
If 2, 1, and yes, 0. Yeah, because it can be 0 to n minus 1. So definitely it can be 0. Okay? So if n is 1, so this means the L can only be 0, right? But if n is equal to, so this means n can be 0 and 1. Okay? And of course, if n is other number, you can get what the L be. So this is very important. And also remember what is L. L is from 0 to n minus 1. Okay? This is the second quantum number. So now, so before introduce the third and the fourth ones, we need to introduce, we should know more about what is n and L. What are n and L? Okay, so n, we say is 1, 2, 3, 4, right? So n, in here, we can say this is the center, is the nucleus, right? So the outside are electrons. Okay, so we can simply the electrons can be move this here, and here, and here, right? So if it moves here, the close to the nucleus, we call n equal 1. Okay, so all electrons in this orbital, we call it's close to the nucleus. So there are n number is 1. Okay, so and also this for electrons in this orbital, so their n number is 2. Okay, and here is 3. So this is the means of the n number So here we can say the n number means the distance of electron from the nucleus, right? So basically, the inner electrons have a large or small n number. Yeah, small. The outside have a large n number, a large number. Okay, so this also means they are energy. They are energy. Okay, so this is why n can't be 0, right? Can't be 0. So in the atoms, if the electrons have high number, so how about their energy? Their energy are high or low? High, yes. Yeah. So basically, the electrons in outside orbitals have high energy. And in the following, question?
Yes, so N basically means the distance of electrons from the nucleus.
Yes. It also means they are energy. Because their energy can be use the n number, and I will introduce how to determine their energy later. Okay, but here you just need to know the n means first is two things. First is the distance, another is energy. Okay, this is what about the n numbers. Okay, the second one is L. L is called angular momentum quantity. So the L means the shape of the electrons, the shape of the volume of space that electron occupies. It's like the shapes of electrons. So we know L can be from 0 to n minus 1, right? So for example, if n equal 1, so the L can only be 0. N equal 2, so the L can be 0 or 1. Okay, and if n equals 3, L can be 0, 1, or 2. Okay, so what is 0 or 1 or 2? So for example, if L equals 0, we call it s orbital. S orbital. So S orbital, so the shape of the S orbital is like this. It's like a ball. Okay, if one electron is L number is 0, this means its electron cloud. The shape of its electron cloud is like a ball. This is when L equals 0, so its orbital is S orbital. So when L equals 1, so the shape of the electron is like a dumbbell. Okay, like this. Okay? Yeah, question?
So since L is n minus 1, right?
Yes.
So why do we get all the numbers when we say if L is 1,
Yeah.
then n minus 1?
Yeah.
Let's say it's 2.
Yeah.
So minus 1 into 1, right? But
Yeah.
why do you say 0 or 1?
Yeah. Because for example, if n is equal 3, for all these atoms, their L number can be 0 or 1 or 2. So this means they have different shapes. Okay. So for example, when n equals 3, right? So the electron shape, so they have more electrons in this orbital. And for these electrons, they can show different shapes. So for some electrons in this orbital, they may be like a ball, so it's called the S orbital. So, and also some electrons, their shapes can be like a dumbbell, okay, dumbbell. Yeah, dumbbell. So this, if the electron have L equal 1, so it has different shape from the 0. But for example, when n equal 1, so this means it only has one shape. right? Because the L can only be 0. So in this orbital, all electrons only have one shape. Yes, she is 0, okay? But when n in this orbital, when n equals 3, so it has more electrons. And then, so they can show more different shapes, like S orbital, P orbital. And when L equal 2, it's called D orbital. D orbital. D is in D orbitals, so it shows this shape. This shape. So get? Okay, good. Okay, so now we know what does the L mean, right? So what the L mean? So the L means the shape of the electrons, the shape of the electrons. Okay. Okay. So here this slide to show how to determine the boundary of the orbital. So for example, if it is 1s, so this is, for example, if only one electron in here, right? So it can move in this area. It's like this. So this is called electron cloud. But how to determine the boundary of the orbital? So basically, we just where 90% of the electron density is found for one s orbital. So the boundary is like this. Is here. So inside this circle, okay. So 90% density is in the circle. So here we show. But of course, there are still about 10% outside, right? But we just see this is boundary of the orbital. Okay. Okay. So we introduced the first two quantum numbers, right? So the third one is called magnetic quantum number. Okay, it's like ML. So the ML can be from minus L to plus L. Okay. So what does this mean? So this means the numbers of ML are decided by what? By which one? Yes, by L. By L. Okay. So, for example, if L is 0, we know L is the shape of the electron of the atom, right? So if L is 0, so the ML can only be 0, right? Because from minus L to plus L. So minus L is 0, plus L is 0, right? So it can only be 0. Okay? So this also means it has only one orientations. So this means the ML is about the orientations of the shape, of the cloud shape. Okay? So for example, when L is 0, so L can only be 0, so just only 1, because you know the ball, right? Which direction is the same, right? So it's only one orientation. Okay, when L equal 1, so we call it P orbital. So it's like this, right? The shape. So when L equal 1, so it can be from minus 1 to plus 1. So this means the L can be minus 1, 0, or 1. So it has 3 orientations. So the electrons in p octets have 3 orientations. So which direct orientation like this. So the cloud can be along the x-axis, right? It also can be along the y-axis. It's also just along the z-axis. So when the shape of electron is p, so it has 3 orientations. 3 orientations. It means it has 3 different electron orbitals. Okay. So when L equal to, we call it d orbital, right? D orbital, the shape is like d orbital like this. So it has the orientations of d orbital. D orbital can be, the number of ml can be from -2, -1, 0, 1, 0, 0, 1, or 2, right? So it has 5 orientations. 5 orientations. Okay? Again, and for this context, we will I will give you some questions, and from the questions you can understand more about what is L mean. Okay, so the first one is called spin quantum numbers. So spin quantum numbers is can write like as ms. So this means the number can only, the ms can only be +1, +half, or -half. So what does this mean? So this means the spin direction of the electron, because for each electron, it can spin. It can spin. So when the spin, they have 2 directions, right? One is like this way, okay, this direction, or this direction. So if we write this direction, it's like +half. So this means -half. Okay. So this is why when the electron, when it goes through the magnetic field, some can go up and some can go down. It's because they have different spin quantum number. Okay. So this was also about the magnetic properties of the electrons. Okay. Okay. Now we know basically for one electron we can use Schrödinger equation to describe the electron. And in the Schrödinger equation, there are 4 quantum numbers, right? N, L, Ml, and Ms. Okay. So basically, for each electron, it has its own quantum numbers. Like in the stadium. So when you watch the football game, right? So each one can get a ticket, right? So everyone's ticket are different, right? So and the electron is also like the electron also like this. So each electron in one atom has different N, L, Ml, Ms numbers. Okay. So this is called Pauli exclusion pretty simple. So no two electrons in an atom can have the same 4 quantum numbers. Okay? So here this table to show the N, L, ML, the numbers. For example, if N equal 1, so this means the electrons in the orbital, which is close to the nucleus, right? Nucleus. So if N equal 1, so L can only be 0, ML 0, right? Because ML is from minus L to plus L, right? Okay, so the number of orbitals is only 1, right? Only 1. Because L just 1, 0, 0. You can't find other numbers, right? So yeah, the number of the orbital only 1. And of course, in this orbital, it can has 2 electrons. So 1 is, even though another quantum number is ms, right? So 1 can be plus half, another can be minus half. So this electron, this orbital is called 1s orbital, right? And also it can has 2 electrons. Because here, if 1 can be plus half, minus half. So these 2 electrons have different numbers, right? Okay, and for example, n equals 3, so the L can be 0, 1, 2, okay? And if it's 2, so it means can be these 5 numbers. So orbital, so for this, it has 5 orbitals. 5 orbitals, okay? So this is about the N, L, ML, MS, the 4 quantum number. And we know this is periodic tables, and the atoms are put in this table according to their what?
Mass numbers or atomic numbers?
No, basically electron numbers. Or neutron numbers. No, it's another electron number, right? Also is called atomic number. Atomic numbers. So here we say we can use this model to show this simple model to show the electrons in atoms. Basically, here share. So electrons with the same volume of N is called share. So for example, in this here, how many shares? 3. Yes. So this N 1, 2, 3. Okay. So in one share, they may have the subshare. So subshare means the electrons with the same volumes of N and the L is called subshare. Yeah, question.
Yeah, so the third share there is the outside part. It's outside.
Yeah, the share is this is one share. This is another share. Then this is another share. So in one share, they may have subshare. Subshare means also in this share, in one share. For example, this one it has subshare or not? When n equal 1. No, it doesn't. It doesn't have a subshare, right? Yeah, because the L number can only be 0, right? But when n equal 2, so the L can be 0 and 1. So how many subshares? Yeah, good. Your Chinese is nice. Yeah, you should learn some Chinese in China. Yeah, you said too. Yeah, good. Good. Yeah, when you're in foreign countries, basically it's very helpful if you can learn some log language, you know? Yeah. Okay, so when equal 2, so it has 2 subshells, right? So when n equals 3, how many subshells? Yeah, 3. 3. So the 3 is 0, 1, 2, right? So this is, yes, subshell. Okay?
Yeah.
So in one subshell, they may have one more octets. So octets, it means the electrons with the same volume of N, L, and Ml. For example, in this subshell, how many octets? 3. Yes. 3. Because they can be, the ML can be -1, 0, and 1, right? So these 3 has same N number and L number. Okay, so it has 3 octets. And for this one, how many octets? 5. Yes, good.
But
Okay. Yeah,
so you cannot count from the diagram there. You have to calculate.
Pardon?
So you cannot count the number of shells from that diagram there. You have to calculate.
Yeah, from here you need difficult for you to know how many, right? But from using this way, of course, you must use it this way. Yeah, to calculate, to think out how many octets. Okay. Now question: how many electrons can an octet hold?
Maximum?
Yes, so it depends on magnetic, the force quantum, right?
Because isn't it the first shell is as 2?
Yeah, I say that for the, yeah, 2. Yeah, the answer is 2. Why? 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 Because they have the same N number, L number, and M number. They also may have different MZ number, right? Yeah. So here we can see if the N, L, and ML are fixed, then MS can be half or plus half or minus half. So the equation of the electrons can be this one or this one or this one. So this means it can hold 2 electrons. So in one octet, it can only have 1 or 2 electrons, no more than 2, right?
So,
Yeah.
is what we're talking about here different from the number of electrons that can be held in the shell?
Oh, in the shell, basically the shell is made by octets. So you just need determine the numbers of electrons in the octets, and then you can figure out how many electrons in the shell.
Yeah, because since you said the orbit can hold only 2, right?
Yes.
Yeah, but if you remember, if you're trying to bring out the fact that by using the electronic shell, it can even go up to 18 or 30 something.
Yeah, but for each shell it has more than 1 octet.
Oh.
Yeah.
Okay, I understand.
Yeah, and then for each octet it has 2. So of course for one shell it's maybe 18 or
So the
8.
thing is, as we go on with the number of shells, the number of orbits also increases.
Yes. So because when the n increase, so the octets, the numbers of octets also increase. So they can hold more electrons. Okay. Yeah. So here we just discuss only one octet. Okay. If one octet, for one, if these 3 numbers are fixed, this means it's 1 octet, right? So we can only change the MS number. So MS number can be only plus half and minus half, so we can only have 2 electrons. Okay? So yeah, have a short break.